If a gas is compressed by 400 milliliters to 250 milliliters at 1.5 atm under constant temperature, what was the initial pressure? So first off, we need to figure out what law we are using. And notice here, I've got 2 milliliters, and it says it goes from one thing to another, which means, again, we have got 2 data sets. We've got a beginning and an end, which means this is combined. There's no grams, no mole, so there we go. Yeah, we should say without gram or mole. So yeah, this is totally combined, which means we're going to do the whole P1V1 over T1 equals P2V2 over T2. Okay, now this has something new to it. It has a constant. You can see it says there is constant, I messed that up, constant temp. What that means is we can just cross out the temperatures then, because you cancel constants. So remember, whenever you have a constant, you just cancel it, cross it right off of what you're working with. So since that's constant temperatures, I just get rid of temperatures, and there we go. Let's identify what I've got here. I've got a gas is compressed from 400 mLs to 250 mLs. So this is my V1, and this is my V2. And it says at 1.5 atm. So it's saying that this V2 is connected. This 250 is connected to the 1.5. So that means this is not P1, this is P2. This is the second pressure. And the question goes, well, what was the starting pressure? So we're looking for P1. So P1 will remain our variable, and it's going to be multiplied by 400 milliliters. This is going to be equal to 1.5 atms times 250 milliliters. I'm going to do my unit trick. I have milliliters on one side, milliliters on the other, so they will cancel, which means my missing unit is atms. So I'll just write that at the bottom so I don't have to worry about my units anymore, because everything else will cancel. It's a nice little shortcut. It's pretty handy. So what I'm going to do then is I'm just going to take both sides and I'm going to divide out the 400. That is where my variable is, because I want my variable to be alone. So the 400 will cancel, and I'm left with my math over 1.5 times 250 divided by 400. And that gets me an answer. If I look at the problem, there are 2 sig-digs in the problem, so I'm going to only want 2 sig-digs in my answer, which means 0, which is a placeholder, 0.94, my 2 sig-digs. And there we go. That's it. This one is a very common combined gas law example. You've got some canceling going on, but other than that, you know, this is plug and play algebra.